Hi. Oh, that's loud. Welcome to the last session of the day. Normally, I love to take questions during my talks, but if I can't hear you, it's because I've been like partially deaf for the past few weeks. It's not that I'm ignoring you. At least that's what I've been saying at home. It's true. So, we're going to be talking about some features from C# 8, 9, 10, 11, 12, and onwards. There's a lot happening in C# as a programming language. And we're going to go back a little bit and talk about some of the features that have been added the past few years. And if you were at my session in Porto, I believe 2.5, 3 years ago, there's been a lot of changes in the language. Before we get to that, my name is Filip Ekberg. I do a lot of talks on C#. I have a few courses on Pluralsight on different types of C# subjects. If you do have any questions that arise after this, feel free to ping me on Twitter, send me an email. My book is free to download as well if you like to dig into that. So enough about me. Let's talk about C#. This here is a map over the features that have been added in C# over the years. There's quite a lot of language features, but if you look at the fundamental building blocks, you don't need much. You just need a couple of ifs and elses and switches and all of that to make a nice program. But what all these language features allow you to do is to express yourself in different ways to better build software that hopefully doesn't crash, and hopefully is easier for other developers to understand as well. One example of that is both generics and the async and await keywords. Both of these language features were, in its way, kind of fundamentally changing the way that we look at approaching those different problems. Generics changed the way that we work with collections, and async and await changed the way that we work with streams of data or data that's retrieved asynchronously. And the aim here is to get language features into the language that always do this, that always change the way that we want to approach problems that might have previously been hard to express. And we're going to look through a lot of the features that have been added, but also look at what's coming in C# 11. What's pretty cool with C# and VB as programming languages, and F# as well, if I forget to mention F# in this context of being open source, this is a hate storm after this. So C#, VB, and F# are all open source. You can go ahead and contribute your language features if they're approved. All the discussions around which features to add to the language, that's all done in the open. You can participate in the discussion. You can see the ideas behind why a certain language feature might be valuable to the language. You can even just help out, update the documentation if you so like to. So with that out of the way, if we just look at a few highlights, C# 7 has been around for quite a while now. But one of the interesting things with the fact that this is open source is that they've been able to add so many features into the language. So I don't want to alienate anyone. The first feature I want to talk about is Tuples, or Tuples. Depending on where you're from and how you like to pronounce it, we're talking about the same thing. Prior to C# 7, we had to work with tuples in a rather interesting way. We had this type called tuple, and this was a generic type, and you access properties and fields like you do any normal class. The problem here, excuse me, is that item 1, 2, and 3, they don't have any proper naming. So this was really hard to work with. So as of C# 7, this is now a first-class citizen in the programming language. So as you'll see here, tuples in C# 7 allows you to construct this grouping of elements where each of the different things you put in your tuple are fields. And you get names for those fields during compile time and during the work that you do in your program. It's not a part of the actual compiled version. So why are we talking about this and why is this such a big change? The fact is that this is kind of one of those things that was needed to be added to allow us to easily work with pattern matching, which was introduced in C# 8. Together with tuples, we also got something called deconstruction, which is a way to take an object and pull that apart into different types of variables and different types of pieces and make it look like a tuple. It's sort of they're totally different things, but they were used together. And hopefully you'll understand why in just a second. If I have a class, let's say that the class exposes a name and an age property, And I simply just add this method to this class. What this now allows me to do is to deconstruct this object. Look at this here. I have an instance of a person, and I just dereference that or reference that into something that looks like a tuple. What happens here is that this instance is deconstructed into two local variables, a name and an age variable. The compiler will make sure that it calls the deconstruct method to do this. It's a handy feature, but used on its own like this here doesn't make much sense. But if we keep this in mind, this is one of those fundamental things that we need to understand when we start looking at the other new features as well. Tuples and deconstructions are often used together. As you'll see here, if I have a tuple here that I defined in line, it contains the variable or the value 10 and 20, that is then deconstructed into two fields that will exist on this local variable. Might look very weird, but this is kind of the new way of building things in C#7. But again, you wouldn't write this just out of the way like this here. And a better example is if you have an instance of coordinate, you then deconstruct that into something similar, right? All this is capable by introducing a method called deconstruct, and you can add this on any type of object. And what's interesting is that we're going to talk about something called record types, which is a new way of creating reference types in C#. This is added automatically on that. So if we skip C#7, and there's a lot more added to the language as well, but now we're going to be talking about C#8 and beyond, because this is where things quite changed a little bit more drastically. There's a lot more changes in the language. And you'll see that if I'm just going to list out a whole bunch of different language features. I'm not going to be able to go through all of these here, but just to give you an idea of the amount of language features that was added in the language. Got something called read-only members, default interface implementations. There's pattern matching enhancements. And why I'm saying enhancements here is because the language designers added a first version of pattern matching in C#7. But at that point, it didn't make much sense to use it. It's actually not up until, I would say now, that I see this used quite heavily in new C# projects. Got something called using declarations, static local functions, and then another really big thing called nullable reference types. It changes the way that we look at nulls, and we'll get into that as well. The highlighted portions, the one that I bolded out here, that's what we're going to be looking at a little bit more in detail. We also got something called asynchronous streams, which is a way for us to consume data that's streamed into an application. Async disposable, ranges and indices, and some null handling as well. If we want to use this in an old project, we can't simply tell the compiler that now I want to be using C#8 or C#9. What they also made sure here is that they changed the way that they look at deploying the language versions. So to use C#8, you need to use Visual Studio 2019 or later, together with .NET Core 3.0. C#9 requires .NET 5, C#10 requires .NET 6. Each version of .NET would have a corresponding C# version. This is because they want to be able to do runtime changes for the language as well. That means that they can do even further or bigger changes to the language that is also tied into changes in the runtime. In the past, that was a little bit more difficult because the teams were, I believe, more separated in the organization, but now that everything's open source, they can just help each other out. That's great. So if we want to use the latest and greatest, always use the latest Visual Studio. Obviously, that's not always going to be working in new projects. Some of the language features are also available to use on older frameworks, but you have to download some NuGet packages for that. So that's like, for instance, for nullable reference types. What this means is that if we are working in WinForms or WPF, we might not be able to just jump on .NET Core, right? Where we couldn't do that. So they had to also introduce project templates for .NET Core, for WPF, as well as WinForms. So you can use this across all the different types of applications. All right. One language feature that is kind of this I don't know if this is an English expression, but you have like a water divider. So you have one portion of the water on this side that loves it, and then the other people on the other hand hates it. I think most people don't like this, but that's just me. This here is known as default interface implementations. From a perspective of a library developer, imagine that I want to update my package. I want to deploy that out to my millions of users. If I'm lucky enough to have that many people using my project, that's great. But one of the drawbacks with that is that I don't want to break anyone's code. By updating an interface, I require everyone to implement all my new members or all my new methods. With this here, I've now added an implementation to my interface. Looks like a normal class, except there's no instance of the class. What this now does is that it allows me to deploy a default implementation. This doesn't do anything. And a problem with this approach is that if I just download a new version of this interface or the new package that contains the interface, there's no warning that I haven't implemented this because there's already an implementation provided by the library developer. That's something to keep in mind if you ever have to use this. So basically, you can have method bodies on or methods on your interfaces. Now, this requires .NET Core 3.0. So what happens if I have a .NET Standard library? So we're not going to be talking about the differences between framework, standard, and all of that, because that's a whole session on its own. But what happens if this lives in a shared library that's compiled to multiple targets? That would be a little bit problematic. We do get a little bit of help here. I'm going to zoom in here. It's going to tell me that the target runtime that I'm currently building for doesn't support this particular language feature. So the compiler is trying to be smart enough to tell me that you're now using a feature for one of the targets, but it doesn't work. So you have to do something else. This is where you end up having a lot of if-defs and a lot of other ugly code. Anyways, it's a nice addition to library authors. Now, I did say that I want to talk about one really interesting feature of C#, and that's nullable reference types. How many here have had a null reference exception? No one? Everyone. Perfect. Who loves them? No one loves null reference exceptions. I've heard this many times, but someone said that null reference exceptions is one of those things that costed the world the most in terms of crashes in applications, right? And problem with null reference exceptions is that we really don't know that they're going to occur, right? We have to guard against them everywhere, and the code becomes hard to read and hard to understand. That's why they introduced something called nullable reference types, which is, the naming here is a little bit confusing because reference types have always been nullable. You've always been able to set a reference type to null. So what they've actually done is that they've introduced all reference types are not null. And I'll show you that in just a second. We've all had this happen in different types of applications, and we all love it. So how do we approach this in a different way to avoid all of these different types of crashes? Well, we can't get rid of nulls in the language because it's been there forever, and that would be quite a breaking change. But if we take one step backwards, what's the problem with nullability? One of the biggest issues is that we have to add null checks everywhere, in places where nulls might not even be a problem. We have to add it everywhere, and all of a sudden the code becomes really hard to maintain. And we want to add as little code as possible to have the biggest impact. And then it's kind of ambiguous. What does it mean to return null from a method? If I return null from a method that looks for an object, was the object not found? Was there a problem? Did I catch an exception and just returned null? Or what's the purpose? There are many architecturally ways to solve this. A default object would be better. That tells you the intent. If you have a method that explicitly determines that this may return null if this does something, that's great. But we don't want to name our methods based on what they may or may not return, in terms of nullability, that is. A slightly different type of problem with nullability is that it encourages mutability. It encourages us to change objects. And in multi-threaded applications, that's going to be an issue. We want to ensure that objects are immutable, so we are never changing anything once we've created an instance. If you want to change a field or a property, you create a new instance. That way you don't interfere with any other threads working on that data. Because you could end up in cases where you have partial data that's being managed across different threads. So that's no good. So an example of a problem or kind of an ugly piece of code here. In this case here, I have an instance of a class called person. I have to check if that's null. I have to check if the address is null and then check if the street name is not null. We can simplify this by saying, is this null conditional operator to say, well, if the address is not null, go ahead and get the, or sorry, if the person is not null, go ahead and get the address, and so forth. It's still not very nice. It would be better to assume that person in this case would never be null here. I should be able to trust that if I'm in a portion of the code where I need to access the street name of the address, there should be an instance. Otherwise, maybe the compiler can be smart enough to indicate that this could be potentially null based on other types or other things that have happened in the code. So that's where null state static analysis comes into play, where this very handy thing called Nullable or Nullable context is going to solve all our problems. If I add this piece of code inside my namespace or inside my class or inside my method, this turns on nullable reference types. I can also do this on the project level, which I'll show in a second here. What this now does is that it changes the way the compiler looks at my reference types. Everything is now assumed to be non-nullable. This means in this case here, we're going to get a warning. Here, we have a warning telling us, well, string here is not null, so you shouldn't set this to null. Still, just warnings, right? But then it's getting smarter here. Since it knows that I've set this to null at somewhere else, it also knows that it may be null here. So in this case, it would be appropriate to perform a null check. So how about we take a look at a sample application? If I can exit my PowerPoint. Font size is good enough in the back? Perfect. This here is a .NET 6 application. This works with the .NET 5 as well and .NET Core 3.0. So I've gone into the project file. I can also do this from the project settings if I want to do that. And I'm going to add this thing here called Nullable Enable. Now, before I save this, just notice there's nothing. This is just a normal program. It has two classes. There's no warnings. There's no nothing. I have a person class, has a reference type on it called details, has two strings called first name and last name. Now, when I save this here, it's going to change kind of how the compiler looks at my reference types. Hopefully. Look at that. Worked. Now we've got these squigglies here under details, under first name, under last name. Of course, this is just warnings. So if I bring up my warnings here at the bottom, it's going to tell me that details here, let's see if I can zoom in. It may be null because you haven't set this in the constructor. That's good to know. We all know that everyone reads all the warnings. Am I right? So what I can do, I can be a little bit, I can say treat warnings as errors. True, I think is the default, or it's what I set this to. Now when I compile this, hopefully everything's going to blow up. This build failed. Now it looks at these warnings as errors instead, and I can't compile the code unless I fix these potentially null reference exceptions. Of course, that's kind of a big change to do to a larger project. Just go ahead and enable nullable reference types and treat warnings as errors, and everyone's going to hate you. So don't do that. What you can do is that you can enable this for portions of the code. So let's do nullable disable. And now it's only enabled, well, it's enabled for everything else, but you get the idea, right? I can use this compiler directive to turn it on and off. So I could refactor portions of my code. So to solve these potential null reference exceptions, you'd have to introduce a constructor. Actually, let's do this on the person instead. You have to introduce a constructor. Now the warning disappeared from the properties because they shouldn't be the ones that are in charge of setting the values. The constructor should be the one in charge of setting the values. Now it's saying, well, you're not setting these properties. And the problem with this approach here is that I'm now changing the contract to anyone that's using first name. I can't talk and write at the same time. I've now changed the contract of last name. Oh, come on. If you've used the latest version of Visual Studio, you get kind of used to the new type of IntelliSense where it just predicts everything. I just press tab and just knows exactly what I want to write. It just auto-generates all my code. Right, so now we don't have any warnings anymore. That's great, but everyone that's using this class now has to change how they're creating an instance. That's a little bit problematic. I do believe that the null reference exception wouldn't have occurred in this place here. So there's no use in kind of guarding against nulls here. This here is a null guard, sort of, unless someone actually sends first name and last name as nulls, because it's still allowed to do so. Actually, let me show you what that looks like. If I create a new instance for details, go to new details, I have to pass first name and last name, right? If I pass null here, it's going to give me a warning telling me that you shouldn't do this because you're not allowed to use null here, but I can promise that this isn't null. Now, all of a sudden, I've tricked the compiler because I know better. This is not where you should use this bang operator. It's not the best place to put it, but it just shows you that the compiler tries to help you, but it's not always going to solve everything for you. So instead of changing the contract of this details, instead what we can do is that we can go to the root of the problem and we can say that, well, I do in fact want to allow these to be null, and this is where the nullable reference types come into play. I can now declare that my string here is allowed to be null by adding a question mark. Right? Like you've done with nullable value types in the past. I can go one step further just to make sure that this is now using the best practices. I can declare that you're no longer, once you've set this to a value, you're not allowed to change it. This is a feature from C#9 called the init only auto property. So if I set this to init here, I'm only allowed to set this once in the object initializer. And then you can't change it anymore unless you create a new instance. Still have a problem here. It's telling me that details could potentially be null, and I don't want to change the contract here either, so I'm going to allow this to be null as well. Now this is the first, I would say, and the biggest problem with nullable reference types is that you're going to end up with question marks everywhere. And again, it's going to make, maybe it's hard to understand the intent. The idea isn't to end up with question marks all over the place. It's a good way to refactor portions of the code until you're actually at a place where you have a better architecture. But now I can start looking for the places where this might actually cause an issue. As you see here, it's giving me an error here telling me that you're accessing details here, and I know for a fact that this could be potentially null, right? So here I need to do a null guard, right? There's other types of doing null guards as well. I could use, I'm going to show you a pretty cool trick here. We'll do argument null reference exception, throw if null, person dot details. Oops, sorry. Look at what happens with the error at the next line. It disappeared. The compiler is now smart enough to know that this thing here null checks this. That's why I don't get any warnings or errors here at the bottom. Right? That's good. So that's one way of minimizing the places where you have to do null checks. But the root of the problem wasn't really in here either. The problem is that I have one method here that returns null, which isn't really that great. So if I want to change this as well to return something that's a little bit more better, I would say, I can create a new person. I'll show you another new pretty cool language feature. So I have details here, and it's a property. Let's say that we don't really know what type this is. I can use the new target type new expression. I don't have to specify the type anymore, it just figures that out. So if it's a really complex type that you're instantiating, the compiler can figure it out for you, and you don't have to be explicit about the type you're creating. I can set first name to Filip. And then to return this, I can use yield return person. That's pretty cool. I don't have to create a temporary list. I can use the yield keyword to create an iterator for me, and that just corresponds with the IEnumerable of person that I had there at the top. Now, the init only keyword that I added earlier, I'll show you here. I can't just access the person. .details, .first name. I can't change that because it's not allowed. It's an init only, so you're not allowed to change it after it's been created. All right. And if I wanted to actually say that I can return null from this method here, I'd have to explicitly say everywhere in my code where I want to allow nulls. Right? And that's not very pretty. I'd have to add question marks all over the place. But it's better to find those places that could potentially be causing those null reference exceptions. And now, if I build this, hopefully, there's no more problems. And the application hopefully works as well. All right. So that's a null reference exceptions. And this method here relies on something called the null state static analysis. There's attributes that you can add to your methods to do the same thing. So you could say, for instance, that I guarantee that whatever thing you passed into this method, I've null checked that if I return a certain value. And that's exactly what this method here does. If this doesn't throw an exception, it's not null. You'd obviously have to handle the exception somewhere else. You've just moved the problem, but at least it's intentional, right? It's all about intent. All right. There we go. And of course, once you've gotten to a place where you've added all the null checks that you have on the places where it's necessary, where it could potentially be null, you could treat warnings as errors on your build server. And anytime someone checks something in that could potentially be null, you'd get a very nice Slack message from them asking you to turn it off. It's not always going to find everything, but it's a good way of solving a problem that they couldn't solve right now, which is removing nulls completely. Other programming languages like Swift, Kotlin, they make it hard to use nulls out of the box. They tell you that you shouldn't. You have to explicitly say, I want to use nulls. They pretty much do the opposite of what C# did in the past. So let's talk about asynchronous streams and leave the nullable reference type for a moment. Asynchronous streams is a way for, it kind of requires you to understand asynchronous programming a little bit. It's a way for us to stream data. So imagine that I have this portion of this method call here. There's a few things happening in here that's a little bit different from what you might have seen in the past. If you have an asynchronous method, it's called async. That just tells it that it's capable of retrieving data asynchronously. It doesn't mean that the entire method is, in fact, going to run on a separate thread or going to be faster than what it could be. It's just a way for you to enable that capability, so to say. This is then coupled with the async enumerable, excuse me, that's indicating that this is going to give you an iterator that's going to allow you to asynchronously retrieve strings. So each string is going to be returned out of this enumerable asynchronously. And obviously, this is called read lines async, so that means we're going to read something from disk. So we indicate that the data will be streamed, which means that it's just going to read one file or one line at a time from disk and then return that. I can use yield return to do that. So I use yield together with await somewhere in this code here, and that's what performs all the magic. It tells the iterator that there's a new item to process. Now, instead of going through the code in PowerPoint, I actually improved this code a little bit today, which is always a good idea to do right before you go on stage. So what I did here, I introduced this method here called getLyrics. The idea here is that I want to get each line from this file one at a time. We can just imagine that this is loaded from somewhere else. It's loaded from the web. It might be an expensive database operation. So I have this fictive delay here of 400 milliseconds. To open this stream reader, I'm using this using declaration. Using declarations was also introduced quite recently in C#. And what it ensures is that it's going to be disposed of at the end of the method call. And it's quite a lot happening in here. Since this is asynchronous programming, it's going to context switches, it's going to involve different threads. The fact that this here closes the stream to the disk after all of that is done is pretty amazing. Then what I do here is that I together with pattern matching, I say, while there is a line that I can read, and I'm using the var pattern here to say that if this is a string, I'm going to capture this into a local variable. This here performs a null check. It stores whatever read line async returns into that local variable, which is only then available inside this context here. And then I have a 400 millisecond delay, and then return. So this is cool. This is a way to just read stuff asynchronously or read one thing at a time. How do I then consume this? You do that normally when you call an asynchronous method. You do something like this, right? So you say, give me all of whatever this is returning. That's what you normally do. Maybe this is hard to read in the back. Normally you do that, right? But now, you don't do that anymore. Well, instead you say await for each for a line in get lyrics. Right? So kind of changed the way that you look at using the await keyword. So what I'm doing here, the await keyword in front of a for each loop means that each line here is going to be retrieved, or each item is going to be retrieved asynchronously. So if I print this out to the console, hopefully this is going to work. .NET run. Look at that. Works. I think this is pretty cool. And it's useful in cases where you want to stream data into an application. There doesn't, as with any IEnumerable, you don't have to know where it's ending, right? Which is why it's not the best idea to do 2 array on IEnumerables, because they could be infinite amount of elements being streamed into that IEnumerable. There's no ending here. Like we're doing yield return. How do we know if maybe this file here is being fed with data all the time? So yeah, the for each loop allows us to iterate over this data asynchronously. All right. So that's C#8. Quite a lot of features. I've showed you a few of them added to C# from C#9 as well. One of the biggest features added to C#9 is something called record types. It's one of the... We've been waiting for this for a very long time. They promised to add something that looked like record types all the way back in C#6, but it's been really hard to implement. I don't know why, but then again, I'm not a language designer. But there's a lot of complex situations that they had to handle. But it's finally there. We looked at the end-only setters, the top-level statements. I didn't mention this, but the application that I had over here, this is a top-level statement. There's no public static void main stuff or anything like that. This is just a normal console application with just a few lines of code. This actually generates all of that behind the scenes, but it makes it easier to just focus on the code. Maybe not for experienced developers, but especially when you're learning about C# or building minimal APIs, it's nice to just be able to deploy like a single file and have all the logic in one place. Unless it's a lot of logic, that is. C#9 also came with a lot of changes to pattern matching as well, which we're going to spend a bit of time talking about in just a moment. And then there's a bunch of other things as well. it's kind of a lot of features to add to a programming language, just in one iteration of it. If we compare these to other programming languages, I don't want to name it, but the one by Oracle, I'm just kidding. They actually got a lot of features as well, so they help each other out. I know Microsoft talks a lot with other language designers from other teams, like Swift and Kotlin and Java and all of that. And I try to make the best programming language. So what I like about C# is that each feature that they add to the language is in fact, looks and acts very much like a C# language feature. They try to make it so that if you know C#, you're still going to be comfortable working with those features. Some of it looks a little bit odd, and some of it might look very unfamiliar, but once you get into it, it's really nice. And pattern matching is one of those things. The whole idea with pattern matching is that we can look at an object or the different traits and attributes and understand what an object is, and write code that expresses what we're looking for. I might be looking for a particular shape of an object. I might be looking for different, let's say, colors, or if it's an edible fruit or whatever. Might be very different things that I'm looking for. I might be looking for very particular things in a large segment of data. For instance, let's say that I'm looking at the last 128 bytes in a byte array to validate a signature. That needs to be a very specific set of numbers. I could, for instance, use pattern matching for that. Hopefully in C#11 when they're adding list patterns. This isn't really a new concept. The idea of looking at the type and just matching ifs and else, or or just looking at different attributes on a type, has been possible for a very long time. Just as I mentioned earlier, it's just a different way of expressing the intent using less characters, less code. That's more understandable. In this case here, I get the type, I compare the type to what I'm looking for, then I'm looking at a property, and then I'm doing something with that particular object. In C#7, they introduced a first version of pattern matching that allowed us to look a little bit differently at the same type of code, but express this in a little bit of a different manner. Now we can use something called a switch with the object, and instead construct an expression that says, well, in the case of this being an apple, when the color is green, then I want to go into this case block. And what's interesting here is that it's the correct type. I don't have to cast it into any particular type. Once I'm inside this here and the compiler evaluated this pattern and it knows what type it is, I don't have to do anything, right? And then what was introduced is something called a switch expression, which is a different way of working with objects and constructing these types of pattern matches. So here we have the input, and this is the object that I want to construct patterns for. All right, and then I can fill this switch block here, or this switch body, this is known as a switch expression, with all my different expressions. So here, I could say that based on the fruit, what this is, if it matches an apple, then this is going to be returned. So everything on the right-hand side of the expression, just like an expression-bodied member, is what's going to be returned. It doesn't necessarily have to be a string. It could be anything. And you could use this in very interesting situations. You could, for instance, say, give me the result of this operation. If it's a failed result, do this. If it's a successful result, do this. That's a very basic way of looking at pattern matching. So with pattern matching in C#, there's quite a lot of patterns, and this is one of the things that I think is going to be evolved much further over the years. So we see that with the new versions of C#, they're adding even more patterns to allow us to express things that might have been hard to do before. We just saw the type pattern. There's a way for us to look at a tuple and compare different positions in the tuple to different values. There's a property pattern. There's something called a tuple pattern that allows you to match exactly what a tuple is. And we're going to look at a few of these in just a moment. There's a relational pattern to allow you to compare different values. You can do and, or, and parenthesize patterns. You can negate patterns. And you can introduce something called recursive patterns. So let's take a look at a few of these here. I'm going to create a new project. Just a console application. You can call it console app 1. I'm going to use .NET 6, the LTS version. And this here is the new top-level statement that you'd get if you just create a new application. And I need to bring in a file. All right, so this here is a test result. Imagine this is a test result for when you've been to university or done some courses and you've written a test. So maybe if you're like me, you have to do the tests a couple of times before you succeed, especially if it's math. It's not my strongest subject. So we have a public property called number of tests, a Boolean if it's valid when this was tested on. And I've also introduced a deconstruct method that allows us to deconstruct this into something that's just represents this object in a different manner, right? So I can say how many days since the test and if it's still valid. This doesn't have to be in correlation to the properties that you have. This could be, as you see here, I'm computing how long it was since I did the test based on the property value and the date. Then I have future subclasses. If it's a positive or a negative test, or it should be passed or failed maybe. See, I've used this quite a lot, and just now I realized the naming is not the best. Beauty of software development. So let's now say that I want to use this here. I have my test result. Let's call it test result, and let's create a new positive result. Now, I can use patterns in not only with the switch expressions, I can use them with switches or if and else ifs as well. So I could say that if the test result, if I can spell, is positive, this is going to do quite a few things. Actually, two things. One, it's going to ensure that it's an instance of an object. It's actually checking if it's set to a value, and then also making sure that the type is correct. If I want to say if it's not null, I can do that as well. That would match on any different types. It would match on if it's a negative as well. Now, if I want to make it a little bit more interesting, maybe I want to say that, well, if this is a positive test result, and you only had to do this test within a certain amount of tries, then you're a gold star student. So how would I express that? Well, I can use a recursive pattern, which is a way for me to apply an additional pattern that is also evaluated. So first, we check if it's positive. And then I can use something called a property pattern to say, well, if the number of tests is less than or equal to 5, then you're awesome. And if it's more than or equal to 2, you're also awesome. Right? So I can kind of express myself in ways that might have been a little bit difficult before. And what's pretty cool here is that inside the scope here, I think I can capture this as a result variable. And I can use this here as the proper type. If I can zoom in here, you'll see that it says that this is a positive test result. So it was captured into the if statement as the correct type of which it was matched to be. Right? So there's quite a few things happening in here. And what I did here was a few things. I did a relational pattern. I have a property here that could be, it's an integer, and then I'm saying this can be between two values. So I used an and here to say that it has to be more than 5 and less, or more than 2 and less than 5, sorry. We could also use this together with the switch expression to, for instance, dictate the outcome of the test. So based on the test result, I start this switch expression. I can use a discard. Just do this. I can use a discard here to say that for everything that's not matched above, so just like a normal switch case, you have to add the most granular ones at the top. So you have to say, you can't add the default case at the top because then it won't match anything else. So for the discard here, this is called a discard keyword. If you use that, that's kind of the default case. It captures everything. If it's null, if it's whatever. If you don't want to capture null, you say not null, right? And then you can say, if it is null, do this. But the same would be to say discard. Make sense? Now, I can apply a few different patterns here. First, I could do the same thing we did at the top, to say that I can use a type pattern to say if it's positive. Actually, we do not available on this one. So for all the positive tests, I'm just going to return the string positive. And if it's a positive test, let's say, let's use the same pattern we had at the top. Positive, come on. Number of tests is above 5, right? So I can add a lot of different test cases, and I can add a lot of different patterns in here and use the different patterns available in C#. What's interesting is that if I remove this here, that's also valid. So I don't have to check the type if I don't want to. I could say that for all different tests, if it's valid, for example, if it's a valid passed or failed test, right, or negative or positive. One thing you should avoid doing is negating these types of patterns. You can, but you shouldn't. Just as with any code that you write, just be cautious. And this here is interesting because what it's doing, it might not be doing what you want. Do you think this is going to match if it's null? Maybe. This here, the property pattern, will ensure that it has an instance. And then if that instance has a property of called isValid that is true, then I negate that entire expression. So if there's not an instance, this is true. If there is an instance and if isValid is false, it becomes really hard to understand exactly what your intent is here. Yes, exactly what? Try to think about the other developers that come after you that have to maintain the code. All right? Not null makes sense. Using not in other places might be cautious with that. I also mentioned that you can use the positional pattern to leverage the deconstruct method. So I could say that based on how this is deconstructed, so if you go into the test result, I know that I have two out parameters here. And based on what we talked about earlier, I can take an object and I can deconstruct that into a different representation. Based on this here, it returns an integer and a Boolean. So what I can do with this here is that I have built-in support that this here can deconstruct the object for me. If I say that I want to use a positional pattern, I can fill this with exactly the number of parameters that's outputted or deconstructed out of that. So where this makes a little bit more sense is if we use named parameters, is valid, and IntelliSense doesn't help at all here. So what this lets me do is that I could deconstruct the object, and if it can be deconstructed into something that generates true, that's more than 10 days old or 10 days ago, then I want to evaluate that expression. So hopefully this just shows you a few examples of how powerful pattern matching can be and the way that you can express yourself in different ways. There's many different patterns and many different ways to do this. But yes, it is obfuscating your code if you're not using it properly. And I'm kind of intentionally showing you ways to not do this because you should be really cautious when you do this. It might be very easy for you to understand when you write this code. Personally, this approach is fine. If you're very explicit about what you're talking about, in this case here, if I didn't have the name parameter and just said over 10 and true, how would I know what that is? I don't want to force anyone to go in to look at a deconstruct method that might live on a base class in a NuGet package that I don't own. So that might be really hard. So in this case here, I would be, if you have to use the deconstruct, I would say do something like this here instead. use it together with the name parameters, so it makes sense, exactly what your intent is. Okay, so we have, let's see here. Let's talk about record types. We have about 10 minutes left. So I want to show you what record types are all about. Record types is a new type of reference type that was introduced in C#. It all starts with the keyword record. You can have a record class. You can have a record struct. And that's just because it makes sense to allow you to explicitly define that. And it does give you a little bit of code out of the box as well. If you don't specify anything and you just say record, that's going to be a record class. So if we say we have a record called person, this here is now a record declaration. And it comes with something called a positional constructor or primary constructor, where I can say that this person has a first name and it has a last name. And now what happened behind the scenes here is that this here generated a whole bunch of code for us. Code that should make it easier for us to work with reference types. If I create a new, if I create a new person, I have to specify the first name and last name. Berg. And it's immutable by default, so I couldn't say that I want to change any of the properties on this here. First name. I couldn't do that because it's an init-only property. If I do want to get a new person with a new name, let's say that I want to get a person 2. Let's say second person. Person with first name. First. IntelliSense doesn't work very well with the top level statements. I'm sorry. Actually, take my wife's name. So now what happened here is that I've copied the entire instance. This with expression was also introduced with C#9 and allows you to copy pretty much everything. You can copy an anonymous type, you can copy a tuple, you can copy your reference types, and you can do this with the record. It allows you to change the values of the properties that you want to change. But what happens if we have a reference type on that? Would you imagine that it copies the entire reference type, or does it only copy the reference itself? It doesn't perform a deep copy, I'm sorry. So if we have, for instance, an IEnumerable of string, phone numbers, if I have this here, it would copy the reference. It wouldn't copy all the elements in the list of phone numbers. Unless this also was a record. But you can experiment with that yourself. So what's interesting here is that if I compare my first person to my second person, obviously, if I run this here and set the correct project as the startup project, oh, it was perfect. It's going to say false because they're not the same. Makes sense. But if I copy this person and set the name to the same name as I have, and I run this again, and you compare two reference types, normally it returns false because it's different references. But in this case here, with record types, you get value-based equality, which means that it's going to compare each properties. It overloads the equality operator and make sure that it compares all the properties that are available on those different types. So to show you exactly what you get from a record, I'm going to copy this here. There's multiple ways to do this. I've already pasted this in here. So I'm at sharplab.io, which is a way for you to write C# code, and you can decompile that and look at what the code generates. Would be awesome if I could do a white team here, but I don't think I can do that. Oh, perfect. There we go. So let's scroll down here. We have a class called person, which implements IEquatable. It has two private read-only fields. It has an equality contract. It has two properties. It has the constructor. It overrides toString. There's a lot of code in here that's generated by just introducing that record keyword. And where it gets pretty interesting is when it overrides the equals method here from the IEquality operator. It checks that the first name for the backing field is equal to the other person's backing field. So this is in fact doing true value-based equality. And you also get this deconstruct method out of the box. You can use these with the patterns that you might have introduced earlier. So honestly, the record types are really powerful. The only place where you cannot use them is with Entity Framework, because Entity Framework relies on references. And since this is doing value-based equality, that won't work. But for everywhere else where you have a data container or like a domain object that represents some data, or you might not want your entity to flow through the application, you might map that to a record instead. And you get a lot of nice things out of the box. All right. So a few minutes left. Let's talk about C#10 and 11. So C#10 also introduced the record struct, so you can get the same type of generated code. Structs are use value-based equality, but you get all the other nice things that record provides. There's some other nice improvements like global using directives. So you could say at one place in the application, I want to be able to use this namespace, and that just works throughout the entire application. So you don't have to have the using at the top of each file, which is a nice addition. You can see something called a file scope namespace declaration. So instead of having to wrap your entire, let's go in here. Instead of having to wrap your entire file in a namespace, you could say namespace NDC. And this entire file would then be a part of the NDC namespace. And that didn't work because I had that in a top-level statement. They've done some changes to property patterns and done some improvements to Lambda expressions. It's quite a nice set of features as well in C#10. Not as big as in C#8 and 9, but it's still it's a nice set of features. They're looking at, or they have added the static abstract members in interfaces, if that's something that you want to use. This is for very specific use cases where you might have custom math implementations and so forth. Right. I've also introduced constant interpolated strings, so you don't have to, you can use that with string interpolation as well. The cool feature is inferred type of the lambda. So in C#9, you had to explicitly declare which type of func that you were using. But now with C#10, you don't have to do that. It's now using the natural type of the lambda. And with the lambda improvements, and I don't know if you've seen the top-level statements, but they've also made a whole lot of improvements to the fact that you can use attributes in your lambdas. So you could, for instance, write a really nice, this here is in fact inside a top-level statement. If I run this, it's going to boot up a ASP.NET web application. There's a little bit of code at the top as well, but basically I can write an entire ASP.NET core MVC application in just a few lines of code. Right, so in about 35 seconds, let's see what's next in C#. There's not a lot. In fact, I didn't want to spend too much time talking about C#11 because based on experience, in 6 months, none of this is going to be in the language. Unfortunately, they're doing a lot of more patterns. They want to add list patterns and slice patterns and span patterns. We didn't talk about spans and slices and ranges and all of that. But for pattern matching, that's going to be a nice addition as well. Name of parameter is one thing they want to add. And the big thing is they want to cache the delegates for static method groups. So if you have lambdas that just points to, or a func that points to a method in your application, and you have that in a loop, it's going to cache that method instead of having to use an additional allocation for each iteration. Adding a new required properties keyword so that you're required to specify the property or set that property when you create an instance of the object. Something called raw string literals, static members and interfaces, and I just showed you a snippet of that. They also want to, this is an interesting change, they want to add something called UTF-8 string literals. So I can take my name here and I can just assign that to a span of byte, and this would generate a byte array of UTF-8 bytes, which is nice if you pass data across the wire quite a lot. So depending on the type of application you're building, this is going to be a nice addition. And then another one is generic attributes. So you could say that you have an attribute that is a generic type. You haven't been able to do this in the past. You had to rely on the type of, and it was quite ugly. So finally, we're getting that. And for those of you that were hoping for something called parameter null checking, unfortunately, the community voted that down after they implemented the feature. Basically, they wanted to allow you to do bang bang, which is the double exclamation marks. So for any parameter that you accept to a method, you add bang bang, and then it automatically null checked that. And if it was null, it threw an exception. And that's another thing, 50% probably didn't want that. But so they removed that. All kudos to Microsoft. That's quite amazing. So if you want to learn more about C# and all the language features in a little bit more slow pace, I have a lot of courses on Pluralsight. I just released a course on a lot of language features. So if you have 7 hours to spare, go ahead and have a look at that. So thank you so much for letting me come here to talk today. It's been a pleasure. Thank you.